Good morning, sir. This is Likita from 19th batch of MRS. In the course of Information and System Security, I've chosen a topic called cryptographic hash functions, and I'll be discussing about this cryptographic hash functions in detail in further slides. The main objectives of this cryptographic hash functions that which I'm going to discuss in further slides are to introduce general ideas behind hashing and hash functions, cryptographic hash functions and its importance, use and application of hash functions, desirable properties of hash function, and simple hash functions. First of all, what is hashing? Hashing is a transformation of a string of characters into a usually shorter fixed length value or key that represents the original string. Hashing is a cryptographic technique that produces hash values using an algorithm or hash function for accessing data or for security purposes. A hash value, also called a message digest, is also known as a digest, is a number generated from a string of text. The hash is substantially smaller than the text itself. And in hashing, a fixed length message digest is created out of a variable length message. This digest is normally much smaller than this message. It plays a vital role in security system that creates a unique fixed length signature for a message or data set. People commonly use them to compare sets of data. Since a hash is unique to a specific message, even minor changes to that message results in a dramatically different hash value. Therefore, it is very resistant to tampering. Now, what is a hash count? Hashing also refers to a search technique or a method of accessing data records where search time is independent of the number of the elements in a collection. Hashing is a user to index and retrieve items in a database because it is faster to find the items using the shorter hashed key than to find it using the original value. For example, we'll consider some of the names as a database like Rasil Akram, Asif Afzal Khan, Khan Atas Samad, and Anuradha Modul. Here, each of these names would be the key of the database for that person's data. A database search mechanism would first have to start looking character by character across the name for matches until it found the match. Uh, But if each of the names were hashed, it might be possible to generate a unique 4-digit key or index uh, for each name. So you might get something like for each name, we'll get some values like here we can see the 4-digit numbers like 1345 Rasil Akram and 3097 Asif Afzal Khan and 406 0 Khan Atas Ahmad and 7350 Anuradha Modul, etc. A search of any name would start consist of computing the hash value uh, using the same hash function. Use it to store the item, and then comparing for a match using that value. This is much more efficient than searching through all the records till the matching record is found, because to find the match across the digits, each having only 10 possibilities, is faster than across the unpredictable value length that each character has 26 possibilities. Now, importance of hashing. Hashing is used to index and retrieve items in database because it is faster to find the item using the shorter hashed key than to find it using the original value. In addition to faster data retrieval, hashing is also used to encrypt and decrypt digital signatures use it to authenticate message senders and receivers. Hashing plays a vital role in security systems where it is used to ensure the transmitted messages have not been tampered with. And also the sender generates a hash message, encrypts it, and sends it with the message itself. The recipient and then he decrypts both the message, and the hash produces another hash form and received message and compares the two hashes. If they are same, then there is a very high probability of that message was transmitted intact. That is, the message transmitted was fine and it is safe. Next, hash function. A hash function is a formula or an algorithm that takes a large data set of variable length and input and returns smaller data sets of fixed length as output. Since the output is smaller than the input data, a hash function compresses an n-bit message string to create an m-bit string where n is normally greater than m. The values returned by hash function are called hash values, hash codes, hash sums, checksums, or simply hashes. Hash function creates a hash value is such a way that it is extremely unlikely that some other text will produce the same hash value. A hash table is used to implement an associative array that can map keys to values. A hash table uses a hash function to compute an index into an array of buckets or slots from which the correct value can be found. Now, what is a cryptographic hash function? A cryptographic hash function is a hash function that takes an arbitrary block for data as input and returns a fixed size bit string as output. The returned value is called the cryptographic value. A cryptographic hash function creates hash value in such a way that any change to the data will change the hash value. Therefore, it is extremely unlikely that some other text will produce the same hash value. And the data to be enclosed are often called the message, and the hash value is sometimes called the message digest, or simply we can call it as a digest. Now, here in the diagram, you can see there are some inputs in which the cryptographic hash function is involved, and we got the output. It is a digest. We can see here in the pink boxes. In cryptographic hash functions, even a small changes in the output would cause a large change in the output. Here we can see. Use of hash functions. Cryptographic hash functions have many information security applications such as message authentication codes, the forms of authentications and digital signatures, etc. Hash functions are primarily used to generate fixed length output data and acts as a shortened reference to the original data. This is useful when the output data is too cumbersome to use it is in its entirety. For example, consider a list of persons' names. Here, name of each person is a variable length, is of a variable length. Searching for a person's name and the list is low. Time required to retrieve each name may also vary in this time. Uh, but if each name but if each name could be hashed to a fixed length integer, then the searching and retrieving of each name will be performed in faster manner, and we can get uh, it very faster compared to before and with constant time. Hash functions are also used to accelerate table lookup or data comparison tasks such as finding items in the database, detecting duplicated or similar records in the large file, finding similar stretches in DNA sequences, and so on. Now I'll discuss about the hash functions used in the cryptography. There are commonly two hash functions named MD5 and SHA-1. SHA-1. MD5. MD stands for message digest. Several MD hash algorithms designed by Ron Rivest are MD2, MD4, and MD5. The last version MD5 is more secured than the previous versions. It will be same for every in every versions if we take any cryptographic functions. The last version, it divides the message into blocks of 5 to 12 bits and creates 128-bit digest. And now SHA-1. SHA stands for Secure Hash Algorithm. This standard was developed by NIST, National Institute of Standards and Technology. This standard is mostly based on MD5. It was generated from, it was developed by referring MD5. Several versions of standard were released like SHA-1, SHA-224, SHA-256, SHA-384, and SHA-512. And this 512 is more but we'll discuss it about SHA-512 in particular. SHA-1 returns a string of 160 bits. Both MD5 and SHA-1 hash functions are built with Merkle-Damgard construction. Now, applications of hash functions used in cryptography. Hash functions are used for verifying the integrity of the message and file, fingerprints of key, authentication, digital signatures, verifying passwords for secure login, verifying the integrity of files or messages. Uh, we'll see about verifying the integrity of files and messages. An important application of secure hashes is a verification of message integrity, determining whether any changes have been made to a message. For example, we it can be accomplished by comparing message digests calculated before and after transmission. Um, for this reason, most digital signature algorithms only confirm the authenticity of a hash digest and the message to be signed. Verifying the authenticity of a hash digest of the message is considered proof that the message itself is authentic. Verifying passwords for secure login. A related application of hash function is password verification. Any user can read the contents of the file, but because the hash function is one-way function, it is almost impossible to guess the value of the password. And also, one way to reduce the danger is to store the hash digest to each password instead of plain text password and the table that is stored in the user identification. And when the user sends user ID and password, the system creates a hash and password and then compare the hash value with one stored in the file. If there is a match, then the user is granted access, otherwise access is denied. And few more applications are file or data identifier and authentication. We'll see file or data identifier. A message digest can also serve as a means of reliably identifying a file. One of the main applications of the hash functions is to allow the fast lookup of the data in a hash table. Being hash functions of a particular kind, cryptographic hash functions lend themselves well to this application too. And authentication as a assurance that the communicating entity is one of that it claims to be. Cryptographic hash functions can be used for providing authentication. And when it comes to digital signature first was proposed in 1976 with Whitefield Diffie of Stanford University as a digital code encrypted message digest that can be attached to a electronically transmitted message that uniquely identifies the sender. When making the digital signatures, cryptographic hash functions are generally used to construct the message digest. A digital signature serves three important purposes. One is it provides non-repudiation, verifies data integrity, and mainly it provides authentication of the server. Properties of cryptographic hash functions. A cryptographic hash function must be able to withstand all known types of cryptanalytic attack. A desirable cryptographic hash function should have the following properties. It should have some particular following properties like a hash function produces fixed length value from a variable length source. It is easy to compute the hash value for any given message. Like if we'll see in particular, it has two resistance like pre-image resistance and second pre-image resistance. Now I'll be discussing about this two in detail. Like for example, given a hash hedge, it should be difficult to find any message such that hedge hash that is infeasible to generate a message that has a given hash. A function with the property is called one-way function, and functions that lack this property are vulnerable to pre-image attacks. In second pre-image resistance, they'll be having two messages like M1 and M2. It should be difficult to find another message like M2 such that M1 and M2 and hash M of 1 is equals to hash M of 2. It is infeasible to modify a message without changing a hash. And also function that lack this property are vulnerable to second pre-image attacks. Thank you.